All right, so problem 6. Who's this Taylor dude? Forgot about him. So we're given f of x, and we're given g of x. Part A, we're supposed to find a fifth degree Taylor polynomial that approximates g about x equals 0. So by them saying x equals 0, you could call this a Maclaurin series or ultimately polynomial, because anything that revolves around with a center of 0 is a Maclaurin. All right, so there's several ways of doing this. Even if you know one way of doing it, it's probably a good refresher to revisit the other ways of doing it. So the most straightforward one would be to figure out what g of 0 is, g prime of 0, g double prime of 0, and so on. Fifth degree, we do 5 derivatives. So those are our initial coefficients. G of 0 is 1. So its fifth degree would be 1 times x minus 0 to the 0 over 0 factorial. Looks like it's a 6 there. Plus g prime of 0 is negative 1. Just looking on my cheat sheet here, what they have listed for derivatives. How's that for lazy? 24 and negative 120. All right, so g prime of 0 is negative 1, x to the first over 1 factorial plus 2x squared over 2 factorial plus negative 6x cubed over 3 factorial plus 24x to the fourth over 4 factorial minus 120x to the fifth over 5 factorial. All right, so that will just become 1 minus x plus x squared minus x cubed plus x to the fourth minus x to the fifth. So g of x is approximately that. There's a fifth degree Taylor polynomial or Maclaurin polynomial to approximate g of x. All right, so that's one way of doing it. The other way, or another way, if we have g of x we know is 1 over 1 plus x. So remember, we've got initial over 1 minus your multiplier, your r. So my initial is 1. And 1 minus, let's see, we're multiplying by x, because that's what, we're multiplying negative x, because r is negative x. So 1 times negative x is negative x times negative x is x squared times negative x times negative x times negative x. Okay, so we can go as far as we want. We get the same answer just based off of the initial over 1 minus r. And yet another way to do it would be to visit this page 477, and there it is. So it's just negative 1 to the n, x to the n, which I could have figured out from these other ones. So g of x is actually sum from 0 to infinity of negative 1 to the n, x to the n. Remember, if you're alternating sign, you need a negative 1 to the n, or negative 1 to the n plus 1. If I plug in 0 for n, I get 1 here, I get 1 here, so that works. If I plug in 1, I get negative 1 times x to the first, so that works. So that's our sigma notation for g of x. That's the whole entire series. All right, so that ought to do it for part A. B, given that the derivative, derivative tangent inverse tangent is 1 over 1 plus x squared. Use the result in part A to find the fifth degree Taylor polynomial general expression for f about x equals 0. All right, so we know, well, we're looking for, we have 1 over 1 plus x. If we wanted it to be 1 over 1 plus x squared, you could replace all of these x's with x squared. So that gives us 1 minus x squared plus x to the 4th minus x to the 6th plus x to the 8th minus x to the 10th. Okay? And we know that is 1 over 1 plus x squared. Okay, so now we also know that the derivative of inverse tangent is this. So if we integrate both sides, we get inverse tangent of x on the left. And on the right, you can integrate each individual term, x minus 1/3 x cubed plus 1/5 x to the 5th. How far do we have to go out here? Oh, 5th degree. So we're good. We're at 5th degree. And if you wanted a general form, if I'm integrating this, so we never wrote this as a general form. So this is it's the same thing as this, but it's x squared. So it's negative 1 to the n, x squared to the n, or x to the 2n. That's what that one is. So if we're going to integrate that one, the negative 1 floats. We add 1, and we divide by 2n plus 1. And that's what our general form of our antiderivative would be, which would, if I plugged in 0, I get positive x over 1, so that's 1. If I plugged in 1, I'd get negative x to the 3rd over 3, so that's all working out all right.